Assalamu alaikum guys, welcome to chapter 9, lesson 1. We're towards the end of the year, so now we're just going to start skipping around the last couple of chapters and point out the important lessons that you need to understand and learn. So today we're talking about correlations, and associations, scatter plots. So correlations basically means what's the relationship between data when it's graphed. So as you see my first graph, all the data is going in a positive direction, right? It's scattered, it's not necessarily linear, but you know that if you were to draw a line as to what direction the data takes, it's climbing up, therefore it's called a positive correlation. Now in a positive correlation, what you need to understand is you have your X and your Y values. The Y, in other words, your output, is going to increase as X increases. So you're going to have to learn how to interpret that. On negative correlation, your data is going downwards. So what that means basically is that your Y, your output, is decreasing as X increases, okay? And then a no correlation, basically the data is scattered all around. There's no specific pattern to it. It's neither positive nor negative. So what that means is that the change in Y, in other words, your output, has absolutely nothing to do with the change in X. In other words, both the X and the Y have nothing to do with each other, and there's no explanation in the sense of it's going positive or negative in that relationship. It's because the data is just scattered all over the place. So your justification more than anything is that the change of Y has nothing to do with the change of X. So today's lesson, guys, is extremely easy. Now, there's no reason not to turn it in by the due date, 1. Number 2, it's not even that long, honestly, and probably if you listen to the lecture today, you should take no more than 10 minutes to do the assignment. So here we are. They want you to describe the data or describe the correlation. In other words, tell us what is the correlation and then also justify. So you're going to have to interpret the data on a graph and then tell us why are you saying that that's the type of correlation. So let's say, for example, we have time, and then over here we have distance. Remember, this is your X, this is your Y. And let's say that your data is in that fashion. So what type of correlation is it? For sure, you know that it is a positive correlation because the way that the dots are falling tend to increase. So we know it's a positive correlation. So this is part of your answer. So it's a positive correlation. Now justify the statement. Why is it a positive correlation? So we take into consideration your output first based on your input. So what's happening to distance? Distance is increasing as time increases. And more than anything, the way you explain it properly, distance increases as time passes. So distance increases as time passes. So always talk about your output based on your input, okay? So let's do another example. Let's say that we have, here is the year, and over here we're gonna write family members. I know that it's not clear, but right here I have family members. It's supposed to be slanted, guys, going up. Let me try again. I'm just in a very awkward position to write that. It's not a big board like the one that we're used to having in class. So basically family members. So in other words, the number of family members. So let's say that your graph looks like that. So is there a trend to it? Is it a positive correlation? Do you see any pattern to it? Is it positive? Is it negative? Obviously, the data is scattered all over the place, and it's neither positive and it's neither negative. So in this case, it's a no correlation. Now, how are you going to explain a no correlation? Go to the number of family members. Family members has nothing to do with the year. You know, as time passes, basically, right? As time passes, families, obviously, children are born, people die, you know, so it's has nothing to do with the year. It's just, you know, what life is, right? So our explanation, number of family members, the number of family members has nothing to do with the year. So it has nothing to do with the year. Okay, so the number of family members in a family has absolutely nothing to do with the year that it is. Okay, so keeping on the same, let's do a negative correlation. So let's say that we're talking about a chicken. Okay, and let's say that we're discussing the age of the chicken and eggs laid. In other words, the number of eggs a chicken is laying. So let's say as it's laying eggs, right, we're seeing a decline. So what could be the reason for that? So we know, number one, it's a negative correlation. And what's the reason for the negative correlation? So the number of, remember we're always talking about the output. So the number of eggs the chicken lays, okay, we're talking about the output. The number of eggs that chicken lays, what is happening? It's a downward trend. So it's a negative correlation. The number of eggs it lays decreases as the chicken ages, right? Now, a lot of kids get that confused. They start putting in, oh, well, you know, when it's a little chicken, you know, it starts laying a lot of eggs, so it's, you know, a positive trend. Don't add more to the scenario than that is necessary, guys. Yes, a chicken is going to start laying eggs, but as the chicken ages, it's not going to be laying the same number of eggs as it did when it was younger, right? So for the same example for myself, I'm an older person, and just because I'm older does not mean I'm going to be having more children, right? Yes, when I was younger, I was having children, but as I got older, I no longer had children. So you have to take into the consideration, you know, what is common sense? What is the norm, right? So in this case, to explain it, number of eggs laid decreases as the chicken ages. So the number of eggs laid decreases as the chicken ages. Okay? So that's basically the first half of your lesson. Now the second half of your lesson is that you have to create a scatter plot, and the graphs are basically going to be done for you. So here we go. It's telling you to go ahead and I think I were a little bit too close, but what can I do? I have a very small area where I am recording. So here we go. So we've got create a scatter plot, state the correlation and justify, and then the data that we have, distance needed to stop a car. So in other words, a car is traveling, and they're talking about speed in miles per hour and distance in feet. So if the car is going 20 miles an hour, it takes 42 feet to stop it. 30 miles an hour, 74, 40 miles an hour, 116 feet, 50 miles an hour, 173, and then 60 miles per hour, 248. So I kind of already started the graph for you all. Now, here we go, guys. So, and I'm sorry I can't do anything about the glare from the chandelier, but the graph is going to be given for you, right? And all you have to do, honestly, is go ahead and put in the data that is in the table. Don't forget that on a graph, you still have to inform the person that's reading it, what are you talking about? So here we need a title, So distance needed to stop car. You can use the same title, you don't have to reinvent it, right? Now, on my speed is going to be on my x-axis, and then the output obviously is the distance it's traveling. So my first ordered pair is 20 and 42. So 20 and 42, I'm going to come to 20. I'm going to estimate where 42 is at. 42 is roughly there because I'm going by 50s on my output. The next value, 30 and 74. So 30, and then estimate where 74 is at. I'm going to estimate it to be about there. And then 40 and 116, go to 40, locate 116. 116 is about possibly there. And then 50 and 173, so it's about right here. And then 60 is 248. So estimate where 248 is at, and notice that obviously as the car is speeding, it's taking longer and longer for it to stop. So now the second part was also that you needed to state what's the correlation. So we know that it's a positive trend. In other words, the data is increasing. So what is the explanation? So of course I'm gonna have to write it here, guys, but you would write it somewhere else because I'm limited in the size of the board. So the explanation to this basically is the positive correlation. And it means that distance needed to stop a car increases as the speed is traveling at a faster rate. Okay? So it's a positive correlation. And then of course, you can use your own words. You don't have to write it as long. But distance needed to stop a car increases, or it is more, as a car is traveling at a faster rate. So distance needed to stop a car or a moving car, okay, increases as the speed increases. And I'm sorry that I'm writing on the graph, but you got to see the graph before I wrote the final answer. So it's a positive trend, and it's a positive correlation. Distance needed to stop a moving car increases as the speed increases. And if you can shorten that statement a little bit more, that's fine as well. Whatever makes sense, as long as you're talking about the output based on the input. So inshallah, you found this lecture very easy. The next lecture, we're going to feed off of this a little bit more. I'm going to be doing a supplement, and I think it's going to be a fun activity. We'll see, inshallah. A lot of times, in class, it's really, really fun. Alone, you might want to call one of your friends and you might want to do the assignment together, which I'll allow you to do that. It's not a problem because it's funny to discuss how we're going to be justifying statements. So if you're discussing it with a partner or a group of friends, then that's fine. And let's see what kind of answers you get. But we'll wait to that till next class, inshallah. Assalamu alaikum.